So here I'm going to use R sub x and R sub y to represent the rate of each of these machines. And so this would be, the units would be fraction of a job per hour. Same for the R sub y. And that just makes it easier for me to visualize what's happening in this question. We're told that the machine X first does this job, half of the job. So that means if the rate is R sub x, and let's say it takes t1 hours for machine X, then the rate times time would be half a job. Same situation we have for the machine Y. It does half of the job, so whatever its rate is and the time it spends, that would be equal to half. The condition we're given is that the total time, t1 plus t2, is 16. So we'll leave it at this point, and then the question is how many hours would it take machine X working alone? So if I know the rate of machine X, then I'll be able to answer that question. So let me start with statement 1. If they're working together at their respective constant rates, they can perform the task in 6 hours. So the combined rate now is Rx plus Ry. Because these are rates, I can just combine them because it's fraction of a job per hour. Same thing here. Think of it as number of units being produced per hour. So those I can add. And if I multiply by the time, 6 hours, that means they will complete the job here. And some of you are probably familiar. You can directly have written that the rate is 1/6 of a job an hour. This is the combined rate, and that has to be the sum of those two. So here what I'm going to do is to represent the rate in terms of the time that was I defined here. Same thing with R sub y, the rate of machine Y. And some of you might be able to directly write it in that way, but I found that confusing. So this kind of helped me put a better structure to this. So if I write the rates of X and Y in terms of T1, T2, this is the equation I get from statement 1. I also have that equation. So I do have two equations. Let's see where it goes. I'm going to multiply both sides by 2. So it becomes 1/3. And then if I add them, T1 plus T2 over T1, T2 is 1/3. You'll notice this one is given to me as 16. So I get product of T1 and T2 is 48. So my two equations are these two. Can I find a unique value? So what you'll find that these two, if you eliminated one variable, meaning replaced T2 in terms of T1, you'll get a quadratic. But you can also guess the answers here. What are those two numbers? 12 times 4 is 48. 12 plus 4. So my solutions are T1 could be 4, T2 is 12, or 12 and 4. And you should try to plug that in. But in general, whenever you see these quadratics in word problems, you can usually kind of guess those answers. So those are my possibilities, but you'll notice that that means the rate of machine X, which is 1 over 2T1, will be different. If it was 4 hours for T1, it would be 1/8 of a job an hour, or it is going to be 1/24 of a job per hour. So it would either take 8 hours to complete the job or 24 hours. We don't have a unique value. 1 alone is insufficient. 2 just tells us that the rate of machine X is greater than that of machine Y. That alone will not give me anything with all this information to solve for that. But if we combine the 1 and 2, if the rate of machine X is greater than that of Y, that means it would take it less time. So it's going to be the first one. It rules out the other one. And so that way now we have a unique value for T1, and therefore we have a unique value for the rate of X, and we can answer the question definitively. So the answer is, both statements together are sufficient. Answer is C.